Okay, moving forward, let's check this out. We're going to find dy over dx by implicit differentiation, looking at some more challenging implicit equations, starting with this. 2y to the third plus xy equals 9. Okay, so first step, we need to take the derivative with respect to x of both sides. I'm just going to write this. I think that's a good first step. When you're doing work, especially once you get comfortable, you don't have to write this step. But I think it's a good thing to do in the lecture, slow things down a little bit. Okay, we're about to take the derivative of the left. It will equal the derivative of the right. So how is this going to play out? Okay, so we've got our derivative involving a y here. So we'll have to think through that and how the chain rule will affect it. Also, x times y. When we go to take this derivative, it's going to need the product rule because we are multiplying x times y. And then we have the derivative of 9. Hopefully we can take care of that too. All right, here it comes. Oh, yep, there's my point, right? Product rule right there. Be really clear. That's easy to miss, really easy to miss, especially because the two variables. But we are multiplying. You're multiplying two things. Got to be product rule. Okay, here it comes. We'll look at this one piece at a time. So we've got our 2y to the third. So it's going to act normal at first. The 3 multiplies down, it becomes a square, 6y squared. But then, because we need to apply chain rule, the inside is the y, so we multiply by the derivative of y, which we simply represent as dy over dx. So the derivative of 2y to the third is 6y squared dy over dx. At this point, a lot of students recognize, hey, somebody in the class will raise their hand and they'll say, so can we just say anytime we take the derivative of y, after we do the normal process, whatever that means, we just multiply that by dy over dx? Yes, that is absolutely true. Just do your derivative as normal, and then at the end of that, multiply by dy over dx, and that will account for the chain rule on the y. Exactly. And that's going to be really helpful thinking of it that way. Okay, let's move on. So then we're going to add, it turns out I wanted to put this product rule inside parentheses for whatever reason. I chose to put parentheses around the whole thing to really point it out. Let's talk about this product rule. All right, so the derivative of x is 1. That's normal as we know it. So we got a derivative of x, and then we leave the y alone, plus we copy the x, multiply by now the derivative of y, which is dy over dx. So we've got derivative, copy, copy, derivative. Okay. And it equals, well, 0. From here, we need to isolate the dy over dx. And you know, the way you do that, it's almost like dy over dx. It's just like a new variable. It's like one object. So it behaves just like the x or the y would behave. You know, we can, do anything with x or y we can do with that entire piece, dy over dx. Well, let's get rid of our parentheses. We don't need that, or the 1 times. Okay. What are we going to do now? There's 2 dy over dx's. How are we going to isolate? And we're kind of, it's an algebra situation here. How do we solve for dy over dx when there are 2 of them? All right, here's what we do. The terms that have dy over dx, we're going to keep on this left side of the equation. Here, the one term that does not have dy over dx, we're going to subtract over there. Well, oh, that was anticlimactic. Need to move to a new page. Really windy this afternoon for me. San Diego windy. Anyway. Before I moved here, I lived out in the desert, and this would be just a nice, relaxing afternoon. Nobody would think of this as windy. Okay, anyway. Subtracting that y, 6y squared dy over dx plus x dy over dx equals negative y. But we're still, we're kind of, how we gonna get how we gonna isolate dy over dx? Maybe some of you know the trick is factor it. Factor the dy over dx. You'll have 6y squared plus x times dy over dx equals negative y, and then we can divide that whole thing underneath, and we got it. dy over dx equals negative y over 6y squared plus x. We got our answer. That's kind of nifty. This is as far as we need to go. We just wanted that derivative in this question. You will get questions in the homework that have you, evaluate it at a point, kind of like what we did with the circle. Okay, that's all for now for this one. Let's move on to part B. This will be fun. Okay. E raised to the x over y, that is division, equals x plus y. Okay, so we don't always have it equal to a constant, right? We can put variables on either side. E to the x over y equals x plus y. Okay, so for our first step, take the derivative of both sides. So I'll just write this for now. And let's think about it. Well, the right side looks a lot simpler. The left side, we got to be careful with. What is going on with the left side? There's a chain rule, right? We have e raised to the x over y. So this is going to be an inside, where the e is the outside. And then even think about the derivative of the inside, x over y. That's a quotient. Oh man, okay, all right. I'm going to take it one baby step at a time. Here's what I'm going to write next. Okay, let's look at that left side. So the big idea here is the chain rule. So the derivative of the e, we know to just copy the whole thing, because the derivative of e to the x is itself, so that derivative, and we copy this part because it's the inside function, right? So all that just gets copied. Then we need to multiply by the derivative of the inside. So for now, I'm just going to write, slow it down a little bit, d over dx of x over y. And I know that's going to need a quotient rule. I'm going to spare myself all that work in this step. On the right side, what's going on? Well, we've got the 1, and we know the derivative of y is dy over dx. Okay, let's go ahead and knock out that quotient rule. Here it comes. So I've got my e to the x over y times, and the quotient rule says low, just copy, times d high is 1, minus high times d low. And well, there we've got the derivative of y again, dy over dx. And that's all over the low squared. And it's still equal to 1 plus dy over dx. Okay, at this point, we have done the implicit derivative, or implicit differentiation is the technique. Now it's our job to solve for dy over dx, which, is algebra, right? Not that it's easy. How are we going to isolate dy over dx? Okay, I see there are two terms, so there's going to be some factoring again. But it's in this numerator. Oh boy, what are we going to do? There's more than one approach. Here's my suggestion. The fact that this is a fraction is really like a monkey wrench in the works, right? So let's make it not a fraction anymore. I'm going to multiply everything by y squared. Oh, well, in a moment I will do that. For now, I'm just going to clean it up. Times 1, and all right, all right, well, maybe this step wasn't needed, but okay, it looks a little prettier now. Didn't really do anything. All right, we're going to multiply both sides by y squared. There we go. Let's push it up to there. Okay. So what happens when we multiply both sides by y squared? Well, on the right side, it's just going to cancel this. So I've still got my e to the x over y needs to distribute, but at least my denominator is gone. And on the right side, hey, no problem. Y squared, boom, boom. Okay. And then, well, it's going to take a few steps, but I wouldn't be surprised if you feel a lot more comfortable at this point. We need to distribute the e. Oh, well, I guess I do that on the next page. It's a lot of writing here because we're copying so many things as we do one little move. So distribute the e to the x over y, okay? And then we need to decide, do we want to put the dy over dx terms on the right, or do we want to move this one to the left? And then the non-dy dx terms, get those together. I decided, since this is negative, to just add this over here, which means I need to subtract the y squared. And again, it's, there's a lot to write here, but at least the hard part's behind us. So I'll subtract the y squared, I'll add this whole thing, and I put it in the first position. Then we're going to factor the dy over dx. And finally, we're going to divide that over. I decided to reverse it, put the dy over dx on the left. That looks a bit more natural, but this is still dividing underneath. Y e to the x over y minus y squared all over x e to the x over y plus y squared. There it is. Notice the beautiful symmetry. I mean, the only difference is a plus and a minus. You would not expect that. What a derivative. That is gnarly. Okay. Let's stop this video right here. We're moving on with this same topic, something new in the next one.